example here. Use an equivalent series resistance to calculate the current flowing in the series circuit below and the potential difference across each resistor. This is a really good question, and this is a really good idea of why we need equivalent resistance. Okay, so the first step in a problem like this, we need to look at the whole circuit. All right, so the voltage in our whole circuit is 9 volts. Okay, that's what's coming through the battery. We know we're getting 9 volts out of this thing. Now, we need to work out our equivalent resistance, which should be quite straightforward. We add them together and we work out that our resistance in our whole circuit is 600 ohms. So, what we need to do now is it says calculate the current in the circuit. How are we going to calculate current here? Divide? Divide will work. Why? Remember that thing? Ohm's law, V equals IR. We know V, we know R, we can find I. So, I is equal to V on R, which is equal to 9 over 600. I think I've left my calculator again. If anyone could do that for me, please. Okay, so 0.015 amps or 15 milliamps. Okay, so there's our current. We've worked out the current in the whole circuit, but we need the equivalent resistance to do that. So now what we can do, what do we remember about current in a series circuit?
It stays the same.
It stays the same. The current in a series circuit stays the same. Everywhere in here, we are going to have 0.015 amps. So we can work out now the voltage that each of those resistors is using up, the potential difference. So let's look at this 100 ohm resistor first. We'll call this number 1, and I'll do it up here. Again, V equals IR. We don't know what V is, but we know I is 0.015, and we know R is 100. So that will give us 1.5 amps. Oh, sorry, 1.5 volts. Oh, so number 1, sorry. Number 1.
So it's a 1.5 voltage drop.
Yeah, so the potential difference across this 100 ohm resistor, if you measured the voltage across that, you would get 1.5 volts. 1.5 volts is what's changing through that 100 ohm resistor. So number 2 now is 200. Okay, and we could just double this one, but let's do it properly. V equals IR, which is 0.015 times 200 now, because our resistance is now 200. So we get 3 volts. So our voltage across there would be 3 volts. The last one, 300. So we'll do number 3. So our 300 ohm resistor, V equals IR. Current is 0.015 multiplied by resistance is 300. So that'll be 4.5 volts. So the voltage going across that will be 4.5. Now, let's have a look at this. Resistor 1 has a 1.5 volt potential difference. 2 has 3 volts. 4.5 added together, add another 4.5, we get 9 volts up here. Okay? So, this is why you need to be able to work out equivalent resistance, to work out either the total current or the total voltage in a circuit. Okay? Work out equivalent resistance, and then knowing that the current is the same the whole way through, you can work out the voltage across any component. Yeah.
You know how Guy was asking about why you deposit a certain amount?
Yeah.
Could that be because it's the amount of energy required to push a single coulomb charge through that?
I think that's probably exactly what it is. Yep.
So the higher the resistance, the more it requires to push.
Yep, exactly. Yeah, that's a much better way of putting it. Well done.